Okay, so let's go ahead and finish this last section of the notes. Other than this, there's a couple of places here on the notes that I left for you to do. Okay, so we can definitely look at those when we have in class. We'll definitely go back and double check those math questions here that we talked about. If you have questions, let me know so that way I can answer your questions regarding the notes. Other than that, when we look through the notes, everything else is filled in. This is the last one here. I think it's wise for you to practice it. Yes, I know it's very wordy, but let's go ahead and practice those questions. They're not very difficult. And then we're going to go and look over homework number 1. Okay? So that way it's videoed. I know that it's here for you. All you have to do is, practice it and then come and watch it on the video to see if you got it right or not. But this first question over here, question number 5. Question says, Wheel of Misfortune is a popular game show that teens like to watch in their spare time. Contestants on the game give the wheel a spin and try to win money and prizes. The wheel is given a rotational velocity and is rotating slows down over time, and the wheel eventually stops. Okay, so they go and spin the wheel like Wheel of Fortune or something. One contestant gives the wheel an initial angular velocity. So that's what the omega and that I is. Kind of like an initial velocity with a V and a little I. That's an omega and it should have a little I. That's what they're just trying to show us. Of 1 revolution every 2 seconds. So I'm going to go ahead and underline that. 1 revolution every 2 seconds. Because of friction, the wheel eventually comes to a rest. So the final velocity is 0. So that's an omega with a little f. In 6 seconds. So after 6 seconds total, it comes to a stop. How many rotations did the wheel make in 6 seconds? So that's where we're at right now. Okay? How many rotations did the wheel make in 6 seconds? Now let's go back and look at this again. The initial velocity was 1 revolution every 2 seconds. So if it rotated for 6 seconds, then after 6 seconds, it ended up with 3 revolutions. Does that make sense? How many revolutions? Well, 3. Because for every 2 seconds, it only, had 1 revolution. So 6 divided by 2 equals 3. That's how I got that answer. Why? Because 1 revolution equals 2 seconds. So 3 revolutions is my answer. See, it wasn't very difficult. You just had to read it. Now let's go ahead and let's keep going. If one 360-degree rotation is equal to 2 pi rad, which is true. Remember, a half a circle is 1 pi. The whole circle is 2 pi. How many rads did the wheel make in the 6-second time interval based on the number of rotations you answered from above, which was 3 revolutions or rotations? The number of rotations times 2 pi equals the number of rads. Okay? This is the wheel's displacement over 6 seconds of time. Alrighty? So again, why do we use 2 pi? We use 2 pi because 1 pi is half a circle, 2 pi is a full circle, and we want to know about full revolutions. So 1 revolution equals 2 pi, right? How many revolutions did my wheel make? It made 3 revolutions in 6 seconds. So in this case then, 3 revolutions is going to equal 6 pi. So if it does 1 turn, which so happens to equal 2 pi, that means that it's 6.28 rads. I'm just kind of writing it all out for those of us who want to see the full thing. And if I have 3 revolutions, which is 6 pi, right? I'm going to get an answer of 50 56.5 rads. That's my answer. How many rads are in the 3 revolutions that my object did? Okay? Because I know that 1 revolution is 6.28, right? But 3 revolutions, which is 6 pi, is going to be 56.5 rads. Okay? Again, we're visualizing it. Remember what I gave as the example? If the lizard moved 3 feet, we can visually imagine 3 feet of a distance. If my object rotated 6.28 rads, now in our mind, we know that that's 1 full revolution. Okay? What is the angular displacement of the wheel after 6 seconds? Alrighty. Well, we have angular displacement here equals the arc length over the radius. Okay? So the arc length over the radius. Now we want to know the angular displacement of this wheel after 6 seconds. And angular displacement is going to be in rads or radians, whichever one you want to say. But let's go back. That is the equation for angular displacement, okay? Which is the theta. The arc length is the S and the radius is the R. But let's go back and look at the definition. Angular displacement is a distance an object moves around the circumference of a circular path or arc. So how far did this rotate? If it started here and it rotated, and after 6 seconds it came to a stop, how far did it rotate? What was the angular displacement? Well, my number, angular displacement, must be in rads. Do we already have a number? We actually do. Our number is 56.5 rads. Okay, after 6 seconds, that's how far it traveled, which was 3 full revolutions. Okay? So they were just kind of wordy here, trying to throw you off. Were you going to use this equation? No, we didn't have our arc length number. We didn't even have the radius, right? We didn't even have this information. We were not using an equation. There wasn't any math. We were just knowing that my angular displacement means how far did it move? Did it rotate 1 time, 2 times, 3 times? How many revolutions did it make? And angular displacement, the number needs to be in rads or radians, whichever way you want to call it. Okay? So there we go. Now our notes are pretty much complete. If you have questions, please let me know. There is one more word or one more space over here that I left blank that I want to answer, but I wanted us to finish those first 3 pages before we fill in the blank. I can't recall where it's at right now, but I know that there's a little space or a little blank that I left. Okay, so we're done with that. Let me know if you have any questions. I do know that there is one more spot that I need to fill in. Okay, the next thing that I want to look at is our homework number 1. We did not have enough time to go through this. And like I said, I am going to use up the whole class time, okay, so I can lecture and go over what I need to go over and talk about, okay, because I'm trying to squeeze in 2 days into 1 class period. And then again, I see you, or we're going to be doing something on Friday. Don't forget the other day of the week, it's just open time for you to complete your physics stuff. Please make sure that your name's on it. Now, this is due Friday. I'm videoing this right now. It's the 21st, Thursday evening, okay? I'm going to put this on YouTube, post it on Blackboard, as well as send it on Teams for those of us who had some questions, okay? But I do want to make sure that we know that it's due on Friday by 1 p.m. Now, next week in class, though, whether it's Monday, Tuesday, Wednesday, whenever, or Thursday when you come into class, we're actually going to go over this together, okay? So please be prepared and have it with you in class next week. Alrighty. Now, the other thing that you need to know about your homework, because now that we're going back to school, even though it's part-time, all of your homeworks will be due the day of the test. Okay? But Miss Munson, I thought we turned it into Blackboard. Yes, you did, but I still want your paper copy. I want your hard copy of your homework. So all of your homeworks need to be stapled together. Okay? That is going to be part of the requirement for your grade regarding this semester. Not last semester because I didn't see you. Okay? So let's go ahead and let's look on here. I'll go through a couple of questions, like I said, and set you up. I'm not going to do it all, but I do want to help you. Let's look at number 1. A beetle sits at the top of a bicycle wheel and flies away just before it was about to be squished. Assuming that the wheel turned clockwise, the beetle's angular displacement is 1 pi rad. What is 1 pi rad? A half a circle. Okay? So 1 pi rad, I'm just going to go ahead and just brain dump a little bit. It's going to be a half a circle or 3.14 rad, which corresponds with the arc length of 1.2 meters. What's arc length? That's going to be the outside edge of the circumference. What is the wheel's radius? Okay, so we've got a wheel or circle, and it rotated, or the displacement is 1 pi rad, which is a half a circle from here to here, which so happens to be 3.14 rads. And the arc length, like if we had a measuring tape, because we can't use a ruler, okay? And it would have been from here to here, 1.2 meters. Okay? So in this equation, we're going to use our angular displacement formula, which is angular displacement equals arc length over radius. And what are we looking for? Question mark radius. What is the wheel's radius? So on here, theta equals S over R. We are looking for R. So look, we can put this into the triangle. S and R are being divided, and then theta. Let's solve for R equals S divided by theta. What is S? 1.2. What is theta? Which is going to be your 3.14. We're going to change it from the 1 pi, and we're not going to put a half a circle. We're going to put 3.14. Go ahead and do your division, and you're going to get an answer. What is radius, the SI unit, just so that way we remember? Radius is in meters because it's a distance. Now, there's one more thing that you need to know. It's really important. Remember, first semester we talked about when we had a negative value, it pretty much meant direction. Second semester is the same. The key word that tells you the direction, they don't always give it to you. But when they do, then you need to go ahead and take that into account. Right here, clockwise. Clockwise is a negative value. So you're going to have a negative, your answer, and then meters. Okay? So I just wanted to make sure I went over question number 1 with you. All right, we may not go over. I might just give you the answer when we see each other next week, because look, I set it all up for you. If you do have a question, let me know, and I will stop and go over that. But I will give you the answer next week when I see you in class. Let's keep going. Earth has a radius from the equator approximately 6,380 kilometers, and it rotates 6.28 rads every 24 hours. If you were floating in space looking down on Earth, What would the angular displacement be for the person standing at the equator for 1 hour instead of 24 hours? Okay, so how far does it go in 24 hours? It goes 6.28 rads in 24 hours. Well, how far is 1 hour? Well, let's go ahead and get the 6.28 and divide it by 24 so we can find how far of a distance in rads is 1 hour. So your answer is going to be blank rads. Okay? Blank rads. What was given to you? That was extra stuff. The radius. That wasn't important. What is the arc length traveled by that person? So if they're on Earth, there's the equator, and they're standing right here, in 1 hour, how far did they travel from here to here? What is that arc length? Is what you're looking for. Okay? So theta equals S over R. Ready? Now you're going to go ahead and use this because now it's important. You have this. Let's solve for this. Okay? You have this number. Here's this number. Solve for that number. And you can put it into the triangle and do that. Alrighty? Let's keep going. Down here is a chart, but it says also give direction. How do I give direction for circles? As a quick reminder, I'm just going to go ahead and brain dump this down. If my object's rotating this direction, counterclockwise, it's positive. If it's rotating this direction, which what we call clockwise, it's a negative value. So let's go ahead and do that. Letter A, what is the theta if they gave you the S and the R? What direction is it going to be? Okay, well, first thing is, I look at this one and I have a positive number here. So positive means counterclockwise. So counterclockwise. Ready? Let's come over here and solve it. We're looking for the theta, which equals, what is my equation? Here it is right here. S over R. I have S of 0.25. R is 0.10. So theta equals blank rad. Okay, so you're just going to use this chart to answer the questions. Don't forget to include the direction over here. Okay, if they're giving it to you, then you need to use it. Let's turn the page. On this page, we have 2 questions down here, and then we have, again, practice this because you're guaranteed to have questions like this, or you're going to have to use your protractor on the test, okay? So let's look at this real quick. First thing is, right, I don't want to hear no excuses. My line is too small. No, you're fine. Just get another piece of paper and then extend it out, right? Don't come up with excuses to not do your work. Get your work done. So I'm trying to get a piece of paper over here so that way I can extend it out. So let's do that. Now the other thing also is it's really nice to have your X and Y axis, especially the one at your 90 degree, which is your Y axis, and have that extended out because it's a really good reference point. So here's what I'm going to do. Remember what I told you in class. When it comes to the unit circle or to a circle, we always start here at 0 degrees and we work our way around counterclockwise, which is 90. And that's why counterclockwise is positive, because this is the traditional way to go through a circle. Next, keeps going, 180, keeps going, 270, and then it ends up at 360. Okay? Now, I know that if this arrow right here traveled this distance at least, that's 180 degrees. So if I go ahead and move my protractor sideways over here and line up all my reference points, this line is lined up here. This line is lined up with my 90 over here. Okay? Then I can use this and I can say 90 to 80, that's 10, 15, 16, 17. So this is 17 degrees. So if I add 180 plus 17, I get 197. So my degrees is 197 degrees. Then we're going to come over here and we're going to use our information that we have in our notes, and we're going from degrees to radians. So what we will do is 197 multiplied from degrees to radians by pi and divide by 180. And you're going to get the answer to go here. Okay? So 197 degrees. This is how I solved it. I just turned my protractor sideways. I know that this is 180. Find this, which is 17. Add them together. So that means that it traveled all the way over here, 197 degrees. Okay? Now go ahead and do number 5 and fill this in. And then you have number 6 and number 7. While riding on a carousel that is rotating, oh, look at this, clockwise. So they gave us a direction. A child travels through the arc length. Arc length is the lowercase s. If the child's angular displacement is, which is theta, 2.88 rads, what is the radius? Question mark r. And we're going to use that same equation that we have for angular displacement, which is theta equals s over r. We're just looking for r. So again, I'm going to put it into the triangle. S and r are being divided, then theta. We're looking for r. So r equals s over theta. Go ahead, plug it in, solve for it. Don't forget r is in meters, okay? And then you have the last one. So I did this one. You need to fill that in. You have to practice. I set you up. You need to come up with the answer. This one you're going to need to do on your own. I set you up on question 1. I set you up on question 2. I explained it and showed you the equation you're going to use on question 2B. I showed you what you're going to do on the chart. I went over quite a bit of the homework for you. Okay? Please watch the video if you have questions. We will go over it in class, so you need to have this ready next week, as well as it's due in person. Even though you submitted it on Blackboard, give it to me on the day of the test. Okay? Alrighty. Have a great day.